Hello friends, welcome back to this playlist of Vartita Learning Platform, which is the algorithms playlist. And in this algorithm playlist, yesterday I discussed one of the algorithm, which was related to the conversion of binary search tree into a min heap. This was the last algorithm that I have discussed yesterday. So this one was there. Convert binary search tree to min heap. Right, so you can go to this one and you can understand that what is the logic and how we can convert a binary search tree to min heap. That was the algorithm that I discussed, and today I'm going to discuss about the code, that how you can convert the logic into the code to convert a BST, I mean a binary search tree, to a minimum heap, right? So you can go through that particular video before you go through the code. Okay, so here I'm going to tell you that what I have done. So here is the array of numbers using which I have created my binary search tree. This is the logic of creating the binary search tree. Insert node is the function which I have used to create the new binary search tree, the nodes of the binary search tree. And then uh, I have done one thing, in order retrieval storage. I'm just doing the in order retrieval of the nodes of the binary search tree. I'm just storing them into an array. This is the array, which is a global array. And in this array, I'm just storing all those elements while traversing them in order traversal. And after storing them in the in order traversal, which means that all the elements will be stored in the in order traversal, means all the elements will be in the sorted order in the array, right? So if you want to display this array, you can do that, and you will be able to see that yes, it was a sorted array. But I have already discussed this thing many times, so I'm not going to show that to you. You can already you can do it yourself if you want to, but I believe you guys know that what is the meaning of in order traversal. So here what I'm doing the in order retrieval. So left, then root, and then right. So while traversing the node, I'm just storing the node value to the temp array at the various indexes from index 1 till 9. I have taken this array as 9 elements because I have 9 elements in the binary search tree as well. So all these elements in this temporary array will be in the sorted order. And then what I have done, I have just reset the temporary index to 0. This is the global variable and temporary index, which I have set it to 0 after doing the in order retrieval storage, because I need to just traverse it again from the beginning while converting it to the min heap. So while converting it to the min heap, what I am doing, I am just doing pre-order traversal. I already discussed in that video that you need to do the pre-order traversal of your binary search tree. And while visiting each of the node in the pre-order traversal, you just need to replace the values in the nodes with the in order traversed values, right? I have traversed the values in the in order and stored this in temp array. And as soon as you visit the first element in the pre-order traversal, you will just copy with the first element of this array. When you visit the second element in the during the traversal, you will put the second element of this array, and so on. So that way, what will happen, that all the elements in the binary search tree will be such that all the root node elements are smaller than um, its left and right child, and this will be true for entire tree. And the root element of the binary search tree will be the smallest element. So that will become minimum binary search tree. Not minimum binary search tree. Basically, I should say minimum heap, right? So this I have done through this program. And what I have done, I hope you might have got the logic here, because I have already discussed. So in this min heap, you can see that I'm just traversing it in the root, left, and right, which is a pre-order traversal, right? So this way, we can convert a binary search tree to a minimum heap, right? So if I run this logic till here, this tree will be converted into a min heap, right? But how we will prove that we have converted it to the min heap? The answer is very simple, and I guess you might have already uh, guessed it, that we will just do a pre-order traversal. And if I do the pre-order traversal after this min heap creation, then that pre-order traversal should give me the elements in the sorted order, in the increasing order. So that will happen here. So we are just going to write a function here, pre-order traversal, and just need to do like if p root is equal to null, then what will happen? It should return, and else we will simply do a pre-order traversal, which is something like this. So here what I will do, I will just print it so that we can confirm that while doing the in-order traversal, we are getting the sequence of the elements in the sorted order. And I hope you might be aware like why it will show you in the sorted way when I will do the pre-order traversal, because I have converted it to a min heap, right? So now if I call this function here pre-order traversal, then in this case it will give you the sorted order. So let's run it, and if I run it, then we will be able to see that all the elements have been sorted in the in order traversal. Okay, just let me do one thing. Pre-order traversal. So here I have done pre-order traversal p-root, convert to min heap, and then pre-order traversal. Okay, there is some mistake, I guess that is why it is not doing that way. So pre-order traversal, if root is equal to null, then should return, otherwise it will go to the left and then to the right, and before that it will print the data. Well, I guess there is some mistake here. But I am not able to get what is the mistake here. Let me just check it. Convert to min heap, p left, p right. No, sorry, it's pre-order traversal I should have called. That is why it is not giving me the correct word. Okay, so that's the logic, and now I just need to run it again, and then you can see that all the elements are in the sorted order after the pre-order traversal. So let's do it. Let's call this again. So pre-order traversal, if I do the pre-order traversal before the uh, conversion to a min heap, then it will give you some other sequence of the elements, which will be like this 5, 2, 1, 3, 12. So this is the original pre-order of the original tree, but after it will be converted to the min heap, then obviously if you will do the pre-order traversal, then it will give you the sorted sequence, right? So this way you can also understand that if you have a min heap and if you want to pick the elements one by one as per their priority, then you just need to do the pre-order traversal of your binary heap, or you can say your min heap, right? So that way you can pick all the elements which are in the order of their priorities, starting from highest to lowest, right? Minimum priority number means highest priority, and highest priority number means lowest priority. Okay, so that's it, and that was it for today, and I hope you might have got the clarity that how it can be done, and now you are very much comfortable. You should be very much comfortable about these algorithms related to the binary search tree. So I will meet soon with some new algorithms. Till then, have a nice day and bye bye, and please don't forget to like, subscribe, and share my videos, and that's it for today. Bye bye.